Assalamu alaikum. Good afternoon, everyone. Welcome to our BUET EEE 316 project presentation. Our project is stepper motor control with microcontroller. I am Shapnil Siddiqui presenting from Group 3. My group members are roll 3, 6 and 11. Our objective for this project is to control a stepper motor using PWM signals produced by a microcontroller, which is an Arduino Uno. We used Simulink for our simulation. Stepper motor is a special kind of DC motor. It performs rotation in small steps. These small steps are called step angles. Usually, there are three types of stepper motor: variable reluctance, permanent magnet, and hybrid. For our project, we have used 4-pole variable reluctance stepper motor. A stepper motor can be driven by these following three methods. In wave drive control and full stepping control, the motor crosses a full step angle in every step, whereas it crosses half of the step angle when driven in half stepping mode. We have used wave drive control for our project. Now Saleh will demonstrate our simulation setup.
This is our Simulink circuit for stepper motor control. Here we use 4-phase variable reluctance stepper motor. All these values are given arbitrarily, but the step angle is given by user. The load torque of the stepper motor is 0. Each positive terminal of stepper motor is connected to positive branch of a 25-volt battery, and negative terminal is connected to ground through a switch. These are the ideal switches. These gate paths are used to control the speed and direction of rotation of stepper motor. There are three types of gate paths: full step, half step, and wave drive. Here we use wave drive as gate paths. These are the scope to show the output. Here we will see step angle and speed of stepper motor as output. And this is our MATLAB code to control stepper motor. Here we use step angle 1.8 degree, then calculate total number of steps to complete a full cycle. This is user input section. The user can give input angle, direction of rotation, and the speed of the motor as input. Then we calculate duration of gate pulse. It will depend on the speed. If the speed is maximum, then duration of gate pulse will be minimum, and if speed is minimum, then duration of the gate pulse will be maximum. And the minimum duration is 0.15 second and maximum duration will be 0.6 second. As we use 4-phase stepper motor, then delay for each phase is T by 4. This loop is used to control the direction of rotation. For 1, it will rotate counterclockwise, and for 0, it will rotate clockwise. And this code is used to plot the output of step angle and speed of the stepper motor.
Now we will see the simulation output. Let us first run the program and input angle, let us say it is 60 degree. Then input direction of rotation, 0 for clockwise and 1 for counterclockwise. First we will see for clockwise. So I will input 0, then input speed. 9 is the highest speed, so let us first see for a medium speed, which is, let us say, 5. So this Simulink will plot the stepper motor response, which will show the position angle in degrees with respect to time. So here we can clearly see that the graph has gone to minus 60 degree. It is negative because it is clockwise. So for every 0.5 second here, we can see 5 steps. Now if we change the speed and keep the input angle constant, the number of steps in unit time will also change. So the speed of increasing will clearly be visible. Now let us keep the input angle constant, 1 for counterclockwise, and let us input the highest speed now. So now we can see the plot has gone to plus 60 degree now. It is counterclockwise, so it is positive. Now for the 0.5 second time span, there are a lot more steps now. So we can clearly see that the speed has increased. We can also zoom into a particular area to see the response more clearly. Now I will change the input angle. Let us say the input angle is now 150 degree. 0 for clockwise. I will also decrease the input speed 2. which is one of the lowest speeds. So now it has gone to minus 150 degree as predicted for clockwise speed. This was the simulation demonstration. Now my other groupmate Jawad will show the hardware demonstration.
Assalamu alaikum, I'm Jawad, role 003, and I'm going to demonstrate our project. For our project, we have used a 5-volt stepper motor, which is powered by a DC source. In our case, it is a LiPo battery. The other terminals of our stepper motor is connected to IRF 250 MOSFETs, which we have used as switches. Then the motor switches are controlled by this microcontroller, and we have used wave drive method to control our stepper motor. The stepper motor has a step angle of 0.1758 degrees and takes a total of 2048 steps to complete a revolution. Now if I give, this is our user interface for driving the motor. If I give input angle of 180 degrees and select the rotation counterclockwise and give an input speed, the speed is a relative scale of 0 to 9. 9 is the fastest speed. So if I select 9, you can see the motor is rotating in a counterclockwise rotation.
Now we are observing clockwise movement. For this, we are inputting an angle of 270 degree and speed of 2, which is a lower speed. Now we can see the motor's clockwise rotation in a lower speed. The motor has completed 270 degree. That's all our demonstration. Thank you everyone for your kind attention.